2. This is our review for our 1 through 75 test. You guys do have the answer key at the bottom, so if I ask, I can get somebody to scroll down to the bottom and check our answer, right? Okay. All right, it says, which of the following, hopefully I got everything recording here, is a factor of x cubed minus 12x squared plus 41x minus 30? All right, what's one strategy we might have towards solving question number 1? Grouping, right? Is that what you said? Solve by grouping? All right, that would have us group these two sections together. What would you factor out of the first section? X squared, okay? So you would get x squared, and inside you would be left with x minus 12. Is that correct? Okay, does that look like we're going to be able to get down to x minus 12 on the other side? Doesn't necessarily look like it. 41, I believe, is a prime number, so I can't divide out by 41. So can we solve by grouping on this particular question? No. But given a list of options, do I have a second possibility for trying to solve this? What else could I do to try? Graph it? Yeah, you could graph it. But I want to be able to solve it algebraically. I want to be able to do the math on this. Okay? What might I do if I wanted to do some math? All right, we'll see if you remember what this is called. Does this bar ring any bells yet? What is this called? Synthetic division. All right, so what numbers do I put in the top bar of synthetic division given this right here? What's the first number I'd put in? 1, and then negative 12, and then 41, and then negative 30. Now, how am I going to know if something works? What should my answer be if it's a factor? What should I get for my last term over here? 0. All right, now if I want to check out x plus 2, what number do I divide by? Or what do I use? I'm going to use negative 2, so let's try that. All right, what do I do with the 1? Drop it down, and then what? Multiply by 1 and negative 2, so negative 2 times 1 is negative 2. Where do I put that negative 2? Under the negative 12. What do I do with the negative 12 and the negative 2? Add them. What do I get? Negative 14. What's negative 2 times negative 14? 28. All right, so I'm going to add those things together. I should get, what, 69? All right, now could I stop here and say, Ryan, this is probably not going to work? You know how I know it's probably not going to work? Because negative 2 times 69 is going to be well over negative 120 something, right? Whenever I add that to negative 30, what am I going to get? I'm not going to get 0, right? So is negative 2 going to work? No, it's not going to work, all right? Because what I'm looking for is I'm looking for something that's going to get me to positive 30 in this last spot. Okay, so I'm going to erase out of here, and we're going to start over. Okay? Now what do I want to try? I'm going to try 5, all right? Bring down to 1, multiply by 5, bring over the 5. Negative 12 plus 5 is negative 7. 5 times negative 7 is negative 35. 41 plus negative 35, what is that? 6. 6, what's 5 times 6? 30. What happens whenever I add those two things up? 0. Is x minus 5 a factor? X minus 5 is a factor. Okay? So do we see how to test answers? Hopefully. Okay? So it's a way to test answers if they give me a list of options. And this would be the work that I would want to see. All right? I don't want to just see x minus 5, right? Show me that you plugged it into synthetic division and it came out with a remainder of 0, showing me that it's a factor. Does that help? Okay. All right. Number two, we're going to come off over here. Researcher visits a wildlife refuge, captures and tags 36 rabbits. The next day, the researcher captures 40 rabbits, and 15 of them are tagged from the previous day. What's the best estimate for the number of rabbits in the refuge? I'm going to use a proportion to solve this. Remember when we had that lesson about polling and that kind of data, survey data, okay? So there's a specific number that goes in all these places. I'll give you a hint. This is the one that we're going to look for, which is the total population. Does anybody know what of these numbers mentioned in question number 2 are going to go above that? $30? No. No. Should be 36. Okay? So what we start with is we start on the top right with the number that we originally tagged. Okay? Number originally tagged. Let me see if I've got this over. Does not look like it. Okay. All right, so we got our number originally tagged. And then it says the next day the researcher captures 40 rabbits. That is a total rabbits captured. So total to total. That's how I know 40 is going to go on the bottom. 15 of them are already tagged, right? And this should make sense, right? Because it's proportional. And I should have a smaller number on top left, bigger number bottom right, because if I captured 36 rabbits to begin with, that can't be more than the total number of rabbits in the population, correct? All right, so from here, I'm going to cross multiply and divide. What am I multiplying? 40 and 36, and what? I'm going to take that total and divide by 15. So 40 times 36 is 1,440 divided by 15, and I'm going to get 96. X equals 96. You see that we get C for an answer. Now, how many of you, whenever you get the review video, watch the review video but don't listen to it? Okay? I want you to understand that that's a really poor idea, because from being in here right now, can you tell that I'm saying more than I'm writing down? Okay, so I'm giving you more instruction verbally than I am visually, right? So if you just watch it, and if you don't have subtitles or something like that, you're going to miss out on what we did there if you don't already know to cross multiply and divide. Okay? You follow me? All right, so my big recommendation is don't just watch it, listen to it. All right, number 3. Which describe the roots of negative 5x squared plus 4x minus 7. This is called, I'm trying to think of the term for it, finding the discriminant. Okay? And finding the discriminant means that we're going to take, if you remember the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. But finding the discriminant means that I'm only doing this portion. Okay? So that means that I'm going to take 4 squared minus 4 times negative 5 times negative 7. Okay, and I'm going to get an answer out of that. I got 4 squared, which is 16. I've got negative 4 times negative 5, which is positive 20. Positive 20 times negative 7 is probably negative 140, right? Negative 140. I got 16 minus 140, which is going to give me a negative answer, right? What's that going to be? Negative 124? Something like that. Does anybody know, in a discriminant, if I get a negative answer, what kind of answers and how many of them am I going to get? What's that? 2 what? 2 complex. All right, and because we're here, and because this may not be the question on the test, all right, a negative value is going to equal 2 complex. What if it was 0? What does a 0 answer equal? 1 real. Okay, 1 real solution. And a positive answer not equal to 0 is going to be what? 2 real. Could be a decimal, could be a fraction, but they will be real. Okay? So a negative answer will give me 2 complex, 0 will give me 1 real answer, a positive answer will give me 2 real answers. Okay, that's something that you need to remember. You need to be able to plug those numbers in. Do we understand why we used 4 squared minus 4 times negative 5 times negative 7? right? And we see how they fit into this b squared minus 4ac. Okay. All right, if you have questions, today's the day to ask, and you guys get the distinct advantage that 7th hour does not get, which is you get me in class to talk to. Okay, they will probably just get the videos. Okay? All right, number 4, calculate the percent change from 60 to 66. Okay, percent change from 60 to 66. What do we think? Is this maybe, let's see, new minus original divided by original? Is that right? Let's try that and let's see if we get the right answer. So we're saying 66 minus 60 divided by 60. Well, 66 minus 60, that's 6, right? What's 6 divided by 60? What's that? 0.1. Okay. What is 0.1 as a percent? 10%. All right, somebody scroll down to the bottom and find the answer to question number 4. What's that? Increase of 10%. Right, because we're going from 60 to 66, so 10% increase. Okay, do we understand that? New minus original over original. Do you need to go get a drink? You sure? Okay. Well, your coffee makes me feel like I need a drink, and so just imagine that you can drink some, and then maybe you won't cough so much. Okay. All right, that's number 4. Number 5, rewrite the polynomial. It's long here in standard form. Then identify the leading coefficient, the degree, number of terms, and we'll name the polynomial. All right, the first thing that we want to do, look through there. What do we notice that's kind of odd about it? It's not in order. So write it in, put it in order for me. What's the first thing that we would write? 2x to the 5th, okay. And what? Plus 3x to the 4th, okay. And what? Minus 6x cubed, okay. Plus 2x squared, okay. Negative 17x plus 3, okay. So it says in standard form, we've done that. What is the leading coefficient? Anybody know what the leading coefficient is? What? 5, she says. She says it's 5. Is that correct? No. What's the leading coefficient? Do we know what a coefficient is? Can anybody tell me what a coefficient is? Is it the exponent to the first variable? No. What is a coefficient? It's the number in front of the variable. So what's the number in front of the first variable? 2. Okay? So 2 is my leading coefficient. Okay, so we did that. What is the degree? 5 is the degree. Okay? Okay, 5 is the degree. Okay? What is the number of terms? 1, 2, 3, 4, 5, 6. Okay. All right, if we need to see that, then we can do, okay, 6. And name the polynomial. Name the polynomial. Scroll down to the bottom. What is the name? A quintic. Quintic, right? Q-U-I-N-T-I-C. Is that spelled right? Somebody down at the bottom? Why is it called a quintic? Because it comes back to the degree. Because it's to the 5th, quintic is name of something to the 5th. Let's go down from there. What if this had been to the 4th? What would we have called it? What would the name have been? Quartic. Okay, what about to the 3? To the third? Trinomial. Okay, 2 squared? What's that? Binomial. Okay, and anything beyond that, it's just a single number, right? So bi, tri, quartic, quintic. Okay, that help us out there? Okay, be prepared for a question like that. All right, 6. F of x equals 7x squared plus 6x minus 2. G of x is negative 9x plus 3. We want to find f minus g of x. All right, so let's go through that process. We're going to take f of x, so 7x squared plus 6x minus 2, and we want to subtract g of x. We're going to subtract all of g of x. Okay, so one of the things I have to be really careful with, again, this is why you need to listen to the video and not just watch it, is I need to take g of x and put it in parentheses. Okay, specifically, especially because I'm subtracting negative 9x plus 3. Okay, because if I don't put that set of parentheses, all I'm going to see is minus negative 9x, right? Which the only thing I would change then is the sign of the 9x, right? But if I put parentheses around it, now I know to distribute the negative to both terms, okay? So I'm going to put a negative in here and here. So I'm going to change this to 7x squared plus 6x minus 2 plus 9x minus 3. The biggest thing that folks forget to do with this is distribute the negative to the 3. Okay, now what can I do with what I have here? Combine like terms. CLT, combine like terms. Am I going to get anything different from my 7x squared? No, so I was right, 7x squared. What about for my 6x? Yeah, what's that going to become? 15x, right? 6 plus 9 is 15. What about for my negative 2? Negative 5. I got a negative 3, so negative 5. All right, that's what I should get, 7x squared plus 15x minus 5. Okay, that's all it needed me to find. Scroll down to the bottom, check, see if that's right. Looking good there. Great. All right. Number 7, what is the solution to the system of equations? All right, so there's multiple ways to solve systems of equations. You could set this up in a matrix. I think the most direct way to go about this is to add these two equations together. Does anybody know why I would do that? The y's cancel. Very good. All right, the y's cancel. What's 3x plus 12x? 15x. Negative 5y plus 5y is 0y, right? Okay, those cancel out. What's negative 14 plus 9? Negative 5. Okay. What do I do with the 15? Divide it. So what does x equal? How about negative 1/3? That should be as a fraction. So if you put that in and you got a decimal, you gave me a decimal on the test, I'm probably not going to count that right. Okay? All right, so my x is negative 1/3, but how am I going to go about finding the y? Plug in negative 1/3. So 3 times negative 1/3 minus 5y equals negative 14. Didn't matter where I plugged it in. What's 3 times negative 1/3? Negative 1. So I got negative 1 minus 5y equals negative 14. What do I do with that negative 1? Add it to what? All right, which means I'm going to get what? Negative 13. Then what am I going to do with the negative 5? Divide it. All right, so y equals what? 13 over 5. Somebody scroll down to the bottom and check my answer. Should be x equals negative 1/3 and y equals 13/5. Is that correct? I'm told that's correct. Okay? Like I said, there's multiple ways to solve this. I don't care which way you use, so long as you come out with the right answer and you can show me your work. If you can't show me your work, it's not worth anything. Okay? Anything where you would say, I did that in my head, you have to be able to show me what you're doing in your head, okay? All right, keep moving here. Number 8. A combination lock like the one shown has 3 dials. Each of the dials has numbers ranging from 0 to 4. How many different combinations are possible with the lock? The mistake that people make with this is they go 1, 2, 3, 4, right? 1, 2, 3, 4, 1, 2, 3, 4, and they take those and they multiply them by each other. How many numbers are actually possible on each dial? 5, because 0 is a number. 0, 1, 2, 3, 4. Well, let's see. 0, 1, 2, 3, 4. Right? 5. Got 5 fingers holding up. All right, so what I have is 5 times 5 times 5, or 5 cubed equals 125. Check my answer. 125. They will very likely change that. They can change that to say it's 0 through 9. If it was 0 through 9, then there would be 10 options, right? Right? And I would get 10 cubed, right? And I would wind up with 10 times 10 times 10. I should have 1,000 combinations, right? Yes. 5 times 5 times 5 equals 5 cubed. Because there's 3 dials, right? 1, 2, 3, right? And it says 3 dials. Okay? So there's 5 on this one, 5 on this one, 5 on that one. Okay? All right. 9. The sides of a triangle measure 7 millimeters, 24 millimeters, and 25 millimeters. Is the triangle a right triangle? How can I check? Draw a triangle. Geneva, what were you going to say? You're close. I'm looking for a specific theorem. The what theorem? A squared plus B squared equals C squared. What's the name of that? Pythagorean theorem. Very good, Maddie. All right. What number has to be C squared in that list? The biggest number, 25 squared. If this is a right triangle, right? If. Okay? Now, it doesn't matter which one the other one's going to, so I'd have 7 squared plus 24 squared. What's 7 squared? 49. And what's 24 squared? 476? Oh, 576. Okay. 576. And I think 25 squared is 625, but I could be wrong. 625? All right. What is 476 plus 49? 625. All right. Because these two things equal, is that a right triangle? Yes. Now, I don't know if they'll change this question up at all. They very could easily ask, what type of triangle is this? Is it acute? Is it obtuse? Right? We would still get a right triangle here, but if this number here, let's say that this had come out to, let's say it had come out to, say, 600 instead. Can anybody tell me what kind of triangle that would have been? No. All right. Okay, so everything is in relation to, let's see, everything is in relation to the hypotenuse. So if the hypotenuse is bigger than the sum of the other two sides squared, then it is obtuse. Okay? If this had been, let's say, 500, then that would have made it smaller, right? The hypotenuse would have been small, would have made it an acute triangle. Okay? So when the hypotenuse is equal, it's right. When the hypotenuse is big, it's obtuse. When the hypotenuse is small, it's acute. Does that make sense? Again, another reason to listen to the video. All right. Number 10, graph the system of linear inequalities. The odds are on this is that it's going to give you 4 graphs to look at, okay, for you to pick from. But let's see what we can do out of this. Okay? What's the first thing I want to graph when I look at something like that? Let's say just this line right here for now. The y-intercept, right? So I'm going to graph the y-intercept. Then what am I going to do? Go down 3 over 1. All right? So okay, and on something like this, right, you would want a sheet of graph paper to be more precise than what I'm going to be. But I'm going to go down 3, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1, okay, and I could go 1, 2, 3 back 1, okay. Now, my line, is it going to be solid or dotted? Dotted, right, because it's not equal to. All right, so now the other thing I have to figure out is which side I'm going to shade. Notice it says y is less than. Okay, what I'm going to notice how 0, 0 sits here, right? I'm going to check and see, is 0 less than 2? Is 0 less than 2? Yes. So because of that, I'm going to shade this side of it because 0, 0 is part of the solution. Does that make sense? We remember some of that? Okay. Now let's graph this other guy. All right. What's the first thing I want to graph here? The y-intercept, which is at -1. And then what do I want to do? Go up 4 over 1. 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. 1, something like that. 1, 2, 3, 4, back 1. 1, 2, 3, 4, back 1. Is this solid or dotted? Solid. Okay. Now I'm going to check my test plot here. Now, granted, it's a little tough because it looks like it's kind of cutting through. I think it's probably 0, 0 is not on the line. Is 0 greater than or equal to -1? Yeah. So I'm going to include this side over here. So your darkest shaded region would be this right here. Okay? Does that make sense? You're going to get a somewhat lightly shaded region up here between the two lines and a lightly shaded region down here between the two lines. But your darkest shaded region is going to be right there to the far left. Does that make sense? All right. That's number 10. All right, let's look at 11. Find the inverse of the function. Inverse of the function. What do I get there for my inverses? Flip the what? Flip the x and the y. Okay? So my inverses are 11, 7, 6, 3, -4, 14. Is that the answer at the bottom? Okay? So I'd make a note for myself there. Hey, whenever it wants the inverse of a function given the coordinates, I need to remember to flip my x and my y's. Okay? The mistake that people will sometimes make is that they'll make that -7, -11, -3, -6, -14, +4. Right? Don't do that. All right, number 11. Let's look at number 12. Find the measure of the reference angle. Reference angles are always what? Huh? Always. Are they ever negative? No, they're always positive. Okay, it's an important thing to get here. All right, always positive. So 325 degrees. Am I going to go clockwise or counterclockwise? Counterclockwise, very good. I want to go counterclockwise 325 degrees. All right, so I'm coming across here. There's 90. There's 180. Right, there's 270. So I keep going here. But I'm not going to go all the way around to 360, am I? No, I'm going to stop. I'm going to stop a few degrees short. And those degrees between my terminal side and the x-axis are my reference angle. How many degrees are there between 325 and 360? 35 degrees. Okay, so 35 degrees is my reference angle. Okay, now when we're talking about reference angles, hopefully we've got this. All right, there are 4 locations. I'm not saying there are 4 degrees. There are 4 locations for a reference angle. Okay, because my terminal side will be in one of 4 quadrants. So my reference angle will either be here, 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 or here. Okay, it will never, ever, ever be here, 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 or here. If I've got it in one of those 4 black spots, I have done something wrong. It is never between my terminal side and the y-axis. Always between the terminal side and the x-axis. All right, we'll stop there. We'll pick it up as much as we can next time. Try to remember we finished question number 12.